these application links between the MongoDBs? Like non-overlapping, like can I use something as hash between them, or can I read the data as it's being replicated?
So it's being replicated. So they're actually reading from the primary, and it's just going through via Bison. So there is it's only using the one protocol, and it is snoopable. So you have to make sure that any over-the-wire transactions or queries that are going on, you have to put them behind your firewall, behind your IP tables to ensure security, because there's no other level of encryption of the data as it goes across. Is that okay? Yeah, cool. And the final slide is about scaling, it's about sharding. And I will quickly skip through this. So you can scale from one node to a replica set and theoretically scale your reads, but most people can't handle inconsistent data. Or most people don't want to handle that either. It might be okay for your sort of application server to be out of date, but not for your main one. So what we suggest is you can shard out, and theoretically, by sharding, you improve your reads and writes, because when you shard, you have multiple primaries. It divides, and you divide a range of data that goes in between the primaries, so you can scale out that way. It is range-based, as I said. The other things it does and it can deal with is it can automatically partition and balance your data. So as you put data in, it will split it up into chunks, and as there becomes a big enough imbalance of chunks, it will migrate them across your shards. And the idea is it will be fully consistent because you have basically, as I say, you still have single primaries, they just have ranges and smaller levels of concern than your previous ones. So how it works, or how you do it, is when you run it, you add your shards in on the shell, and you shard collections. So you don't shard databases themselves, you shard individual collections, and you provide a key on what you want to shard them to. So to begin with, everything has a range of plus and minus infinity. So if you had no data, you would have a look at the configuration servers, and we'll talk about them in a moment, and it will tell you the range for that sharded collection is plus and minus infinity. And you go in and add some more data. And as you add data, this is overly simplified here, but basically, by default, it allows you to have 64 megabyte chunks. So as you add more and more data, and it goes over 64 megabytes, the configuration server and the MongoDB, which is a balancer, will split that data up, and then will change and put them into different ranges. So it will continually do this in the background. It's quite a lightweight process, and it allows you, and it will manage where your data persists to. So, for example, if we only had one shard, the balancer would be continually splitting out these ranges, but they have nowhere else to go to. But as you add more and more shards, it potentially will go and then balance that data across if there's enough of an imbalance in the first place. Now this is the scale diagram. So this is an architecture of a fully quite high-load system. And what we have here, each shard is a replica set. So they're all ensuring that there's high availability for the data that's stored in each shard. We have something called the config servers, of which you have to have 3 in production. And the configuration servers just store the metadata about where the information, which shard, which chunk of data is in. And then at the top we have your application, and we have something called MongoDB, which is the switching balancer. So often people put the MongoDB on the same node as their application, so they can just speak to localhost. And the MongoDB routes all your queries to the specific shards. So if you do a query which is based on the shard key, it will know which shard to go to. If you do a query that doesn't have the shard key, and it will do something what's called a scatter and gather, and it will query across all the primaries and then return that data back in the MongoDB. So it may give it a bit more work to do, but you still can have that flexibility in your queries.
Do I need a connection between the application and all Mongos?
No. So people will just have the application speaking to one MongoOS, and that's it. So if that node goes down,
What's going on if this? Yeah.
yeah, so if that node goes down, the app node goes down, then that's fine because your other app nodes will still have their own MongoOS to speak to. So they will just, in the code, just speak to localhost. The MongoOSs obviously need to be able to see the shards, and they need to be able to see the configuration servers.
Mm-hmm.
And what happens is when you get an imbalance, say there's an imbalance in this shard, the MongoOS will speak to the config servers and divide up the range, so it'll be split out, and then the chunk of data will move across to another node, another shard, and it will still exist in shard 1, but when it's written to shard 2, the configuration servers are updated, and this is where we do have transactions just in this bit of code. Once they declare that the chunk has been moved, they're updated, and now that chunk of data, that range is, the MongoOSs update their configs and know that that range is there. One other thing you can do is, because you have, by default, when you start off with one shard, you can actually change which shard your other collections live on. They might not be split up, but you might want like your users collection on one and then another as you go through. So you can still utilise those parts. But by default, if you start with one shard, all your collections will be on that shard, and then only the sharded collections will be moved, and will be actually, that data will be split across the others. Okay. So, I've talked on more than I wanted to, but here's some use cases of what we're doing or what people are using, and most of them are still very Americanized and centric. That's mainly because this comes from an American sales deck. These are our use cases from people that we know at TenGen. So there are some others, but we don't often get case studies from them. So the interesting ones, things like The Guardian, use it for their content management system. It is now actually their blessed database. So it's the default database for anything of any of their projects, unless there's a reason to use another one. They do use other data stores. They use things like Cassandra for certain parts of their systems, but by default, the default is MongoDB. Another quite interesting one is Shutterfly up there. It's not very big in Europe, I don't think, but in America, had a very interesting situation where it was storing, I think it was storing 20 terabytes of data, having massive problems with its stack, and by switching and by being able to switch out MongoDB and to be able to shard through a large number of clusters, keep all of its data in memory essentially, it allowed it to reduce its response time massively. Other ones we have eBay, O2, use it for their, or Telefonica, use it for their sort of priority moments. So if you're on your phone in the UK and soon to be across the EU, it uses the geospatial stuff to find out offers that are nearby you. Vibe Media is a telephone company similar to just a sort of over the IP telephone company, and they have a massive cluster because they have to keep everything in memory and have no response, like very small milliseconds response time. And then on another side is WordNik, which has a massive data store, but they don't need everything to be in memory. They're quite happy to page fault and go out to disk, but they use MongoDB with just a single replica set, but have, I think, many terabytes of data in their replica set. So, the main thing to summarise is, because of the flexibility of MongoDB, we have seen many different use cases. Some of them have really surprised us at TenGen, and some of them are very interesting. So, like I say, the next slide is to go and download it. But if you haven't already, great. Any questions?
Well, sorry, I guess this is transactional behaviors. I mean, if you only have one writer, I see that obviously you're writing, but I mean, do you lock? Or?
Yes, so currently There is a lot of lock. Well, there's a global lock in the live version now. So in the production release, which is 2.0, that range. So there is a single global lock. So when you go in and you do any write, everything's locked. Reads are fine, so we can do multiple threaded reads at a time. But when a write's going on, nothing else can happen until that write happens. So that has been addressed to try and improve. So in 2.2 it's down to database level. But even so, we're still seeing 30,000 inserts a second going on in systems. So there has been a lot of improvements in 1.8 and 2.0. In fact, 1.6 had some to improve the concurrency and to improve the yielding when we do lock. So originally when we locked, you had to go get something from disk. That could take, depending on your disk setup, that could take many nanoseconds or milliseconds to retrieve that data. We have more and more systems that will then yield that lock back and wait for that data to be paged in and allow the reads to occur and then go back to actually do the inserts. So the amount of time in the lock is a lot less than it used to be. And there are some blog posts that give you examples of it, but of the improved thing. One of our guys, one of our customers at Server Density that do monitoring has issued a load of blog posts regarding how this has impacted his system.
So by experience, you could say that actually you won't, or you hardly ever get into any problems with that locking.
Well, it's difficult to say. So you can get into problems with the lock. I mean, it depends on how many requests per second you have to deal with and what your requirements are. But if you think about, the way we store our data on disk is it's stored in a single Bison file. We may do things like we do add padding on the inside. So if your documents routinely grow, we will actually set some extra space along with them to let them grow into, so we don't have to move them around disk. But if you have one that grew massively, while you're writing it, so it has to relocate where it's going to actually live on disk as well, and you have to update all your indexes, then that's going to actually block more than the thing. So there is some elements of schema design that are more efficient for massively high yield systems. And that's just something you just can't get around, really.
Maybe that's a good point to sort of drill down into a little bit, like some basic advice or rules for schema design.
So, schema design, the one thing is that we do sort of health checks and we go and speak to people. One thing is that we say is really bad is if you have arrays that are unbounded. So basically you have an array that's ever going to grow forever and ever. And the reason we say that potentially could be bad is because it's going to move around on disk. But also, it depends on what level of scale we're talking. If we're talking about an average system, replica sets are great. You can just have 2 of them and you can set up something called an arbiter. And that will allow you to deal with sort of failovers of data. But a single node often can be enough for many people in terms of dealing with their requests per second. But other people, like Viber Media, have to return back within, I think, 4 milliseconds. So they have to split everything up and have to have it all in memory to be able to just get, so they do their operations, the operations applied in memory, and then they return straight back. So it doesn't really matter if their documents are growing because they have they're thinly sliced across relatively, thinly sliced across their cluster. So it kind of, schema design is really an art form. Again, it has to be tested in with your data use cases. If you have an update-heavy application compared to a read-heavy application, your schema design is going to be different. And the best way to test this, or when we go and do like consulting things, we have to see people running through their systems with expected load and then going through to breaking point. Because we find obviously the database is a tier that often slows down their applications because that's always been the way. You have to wait for data to come back and things. But if your data set is in memory, then it's extremely, extremely fast. And if you're using indexes correctly, or indexes in memory, that's fine. But if you have a massive random access to a large data set, then you are going to page fault at times. And unless you can get SSDs, you're going to deal with some cost or more cost. So it's a difficult one. That's our biggest one, is unbounded arrays that people will continually grow, and then potentially they might want things out of those arrays and just actually want to return elements of subarrays essentially. Other ones that are difficult, people will sometimes store trees, as they will do in SQL. It's not a tree database. It's great if it's a small tree and you can have it in a single document, that's fine. You can cache it essentially. But if you're doing it like relationships between friends and want annotations on it, it's the same problem as how you do it in SQL with like your materialized path or all those other types that have your left and right values. You just have more flexibility in how you model it. So I don't know, it's difficult to suggest too much other than that.
I will have to think about where to do the log files for my servers. And I was wondering, MongoDB would be useful or a good approach for it, where I have just tremendous much writes, and at one time someone would go down and analyze the logs, but usually don't.
So
Compared
yeah,
to
so
SQL.
yeah, sure. Well, we have people firing in their logs, but the main thing there is don't have if you've got massive write volumes of logs, then don't have a write concern that says you have to wait until it's replicated out to 2 nodes. Because if you go under a massive amount of load, and you say each write's going to be blocked until it returns back from another node as well, then you'll find that your secondaries can get out of date because of this global lock. This is one symptom actually that we do see under heavy load in systems, that the global lock will actually starve out the secondaries from being able to read because you're doing massive amounts of inserts. So things like a write concern where you actually just a fire and forget write for your logs is a common use case for actually that write concern, the default, just saying like fire, I don't want to wait for a return back. And then as long as it hits that node, you can do your analytics later or whenever you need to.
You also mentioned at the beginning that the notion of table in SQL is actually it's translated in the notion of collection, right?
Yeah.
So I didn't quite get how the collection works, but I'll guess, is that the key that you give to it?
So the collection is
sorry, the question then would be then the locking, I guess would only be necessary on the collection and not on the entire database.
Yeah, that's right. So the collection is just a namespace for where we store metadata against what indexes you have on that table and that kind of thing. So it is analogous as well, similar to what the concept of a table, but you just have documents rather than rows. And when we talk about locking and where the future is going to go with locking, so in 2.2 it's down to database level. The future will then either be down to collection level or potentially extent level on disk. So where you actually write an extent on disk. But it's that level of granularity I think that we will go to, and hopefully in 2.4 it will be at the collection level. Dwight, who's in charge, he wrote the DB locking, and he's kind of thinks that it's not too much of a jump now. He's happy that he solved the hardest problems. So it will get better.
Another question regarding documents. So, in your experience, like in the projects you've seen so far, do people really use widely disparate documents that are stored, or is it more or less similar documents, documents not deviating too much from each other?
So no, people will keep exactly the same documents in. They will have a rigid schema in their data sets.
Okay.
So pretty, or 50 to 90% will be rigid, and then they'll have some level of fluidity. So you might have some level of inheritance that says, like, if you had a tumble log is probably a good example. You might have a post that has like a title, a slug, a URL to go to, and then it'll have some text for the post, and then you'll have another type that has those kind of things, but it has a picture or a video to encode in there as well. So they might just have slightly different fields, or one might be a quote that has a source URL. So people will do that, but you'll find that there's 3 key common points, and then they have like polymorphic data for the rest, so or polymorphic models for the rest of it. But on the whole, it's an anti-pattern to keep different types of documents in the same collection. It's not advised to do, it's not very clear in your intent in your code either. And we have a lot of people using OGM.
Okay.
So Elliot, the CTO, hates them. I maintain one of them for Python. But people still use them massively in the enterprise. People use like Java, people use Morphia because it does things like validation of your data. In the future, we may have that in MongoDB to allow validation as well, but at the moment we don't. And it allows people to be quick and agile when doing their development. One thing I will say is, or will advise if you ever go and use MongoDB and go and try it out, is to not use the save function to update your document. Because what that does, and is something we see quite often, save will write the whole document back. So if something else is in between, you have a massive race condition there. If someone else is in between, you've gone and changed an array and you've had it here and then done something to it and then put it back, and in between someone's updated it, you've lost that. So you need to use the atomic updaters and the updates to push things to array, don't set the whole array, use those operators. These are kind of common mistakes that we will see, and then people will go, I've updated an array 15,000 times, but or appended to an array 15,000 times, but my array is only 100 bytes long. What's happened? And it's just basically they're writing over themselves all the time. So use updates. And updates you can do upserts as well. So you can, if it doesn't exist, you can create a new document with it.
Is there a notion of batch update?
You can do bulk inserts, and you can do bulk updates. So again, you provide a query part. There is a flag that you'll say to do a multiple update, and set that as true. There are some operators that won't do multiples. So if you have an array and you have an array of documents in there, you can do a query that will find a document, and then you just want to update that sub-document. So if we have comments and we have authors for those comments, and one of the authors changed their username or something like that, you want to match all of them that match that and update them. So, or update a specific one that matches it. You can use something called the dollar operator to say, update that position in the array that match, but that will only hit the first one. So there are, in terms of dealing with these sub-objects, there are some advanced query modifiers for you, and it kind of depends on your use case which ones to do.
Is there something you wouldn't do with MongoDB? Or you would prefer MySQL, for example?
Well, I can't do great geo stuff, so I'd use PostGIS and Postgres, because I've used that before. MySQL, I know, I kind of like the agility of it, so I am very happy and used to it, so I don't mind, and a lot of my modelling can be normalised and I'll denormalise when I need to get performance out. So on the whole, we're seeing a lot of people using it, and using it very similar to how they'll use a relational database, because it's new and stuff like that. But it's very flexible for me, and so my previous company, I did thousands of database migrations and had to keep resetting them and running through as we went through our code and things. And as our data set got longer, it took 14 hours to add a column to a database things. And those things I can get away with without doing that. I might have to have some logic in my code to say, if this field doesn't exist, just add it, or just just ignore the fact that it doesn't exist. It kind of depends on the use case.
So it's feature dependent. In the example of geolocation things.
Yeah, so they're only point-based, you
not
can't do...
on the base features of that. As a,
I would say it's not a default, it's an extension to Postgres.
Okay.
Yeah, those things are.
So if you don't need some additionals, you have no reason to use them.
Well, if I had to do transactional things, so we have people that will use it for, we have a number of shops actually using it, so they store their product data in here, because obviously a CD has different metadata to a car, or a sweater or something like that, so, but they will do their financial transactions through multi-phase commits using SQL. So they use both. I mean, definitely get the best of both worlds there, so it allows them the flexibility to do that. Other data things I wouldn't do, if I needed to be able to write all the time. So if I was doing the X Factor and I was doing the voting application, then I would use something like Cassandra Multi-Masters and worry about versions later on. And if I wanted to do trees and relationships, I would use Neo4j or something like that. But I might not store all my data. The point is, I would say, is you don't have to be tied to one single solution anymore. And kind of there is a bit of stickiness there in the SQL world, but a lot of people use things like Memcache and Redis for a caching layer above SQL. They don't realise they're already using two different operation stores. So yeah, we'll definitely get the best out of both.
For trees, is there any real solution for trees?
Neo4j is quite good. So you can do, and you find stuff down the graph, you can annotate the graph so you can find them distinct. But the problem with trees is getting a decent scaling of a level where you can scale out. I don't know how, I think there's a few ones coming out with different data stores, but doing that where you have to shard it is a difficult algorithm. So, yeah.
So would you use Memcache where MongoDB is being used?
We don't see that, we see it taken out. Mainly because if you have everything in memory, you're just reading straight from memory anyway, so it's a layer that people have often taken out. I wouldn't say, there'll be definitely people be using it then. So, yeah.
Any thoughts on connection pooling?
Connection pooling, so the driver should deal with that for you and deal with connection pooling. Depends on what level. So, people after a while, when you have massive sharded systems, you have MongoS's, there's too many of them to have up in your app tiers. So if you have 1,000 plus in your app tier, people will then put them behind a load balancer and round robin them and have a smaller pool of MongoS's.
So how does it compare with CouchDB?
So CouchDB, I'd say it's CouchDB's kind of got a lot of initial growth and stuff, and got me really excited about NoSQL in the first place. So the features are different. I think probably it may be easier to use and pick up because of the native driver support that we have. It scales better in terms of performance, but doesn't do CouchDB. You can have multi-master and things like that. So they're slightly different in terms of that. You would create views in CouchDB. It's not quite the same model. And who knows where Couch is going to go in the future. I mean, Couchbase is a very different product to CouchDB. It's kind of a memcache that persists, but they're adding features to it. So who knows?
There's a nice comparison on the MongoDB page. I never saw a comparison of a vendor to another that's wrote that fair.
We try to be. I mean, we just try to get people to use it, and they generally like it as developers. So that's why we don't do things like benchmarks. We try not to put other technologies down. And cool.
So regarding the unbounded arrays, I just read that MongoDB learns of your collection and adds some padding to it.
Yeah, that's right. Yeah.
How effectively does that work?
So when your documents grow in size, there's something called a padding factor that's put in, and it's just stored in metadata in the database, and it will go up to a level of 2. So you may have data stored or space stored on disk, extent stored on disk, that are twice the size of your documents to allow them to grow into it. And then when you do things like compaction, it will compact up. Because essentially you have holes in your where your data is stored, and that can cause performance issues later on, or too many gaps and stuff, so you might have more data files than you need. So you can compact them down, but the problem with compacting down is you lose the padding factors. But the idea of it is to stop the number of migrations and movements on disk.
So if there are no other questions, we should close. Thank you very much.
No problem.